All right, students. Today we're on 4.1C. And what we're going to be doing, well, first of all, you can join me and take notes on page 111. So we're going to be taking notes on page 111. And what we're going to be taking notes on today is rationalizing denominators with roots. Rationalizing denominators with roots. All right, so what does that look like? Well, let's check out. Well, let's just do a quick review of what we do. Let's say we had the square root of 4 over 16. What would we do with that? Well, the first thing we do is we'd go square root of 4 over the square root of 16. Oh, 4 is in fact a magic number. Square root of 4 is 2. Square root of 16 is 4. So I now have 2/4. So that was pretty straightforward. This actually can be simplified even further to 1/2. And there we go. The square root of 4 over the square root of 16 equals 1/2. Now, that's review. Now, let's check out what we're going to learn today. There is a rule, and I don't know why, but there's a rule that says you cannot have a fraction with a square root in the denominator. So, because of this rule, what we're going to do is we're going to get rid of the square root on the denominator on the bottom. And how do we do that? Well, the easiest way to do that is by multiplying by itself. So here's something Mr. Davies likes to say is you're going to fix the problem with the problem. You're going to fix the problem with the problem. What's the problem? The problem is the square root of 5 on the bottom. How are we going to fix it? We're going to multiply it by the problem over the problem. So what we get is 3 times the square root of 5, right? 3 times the square root of 5 over the square root of 25. Wait a second. We still have a square root on the bottom. Oh, but that is a magic number. The square root of 25 is 5. So we have it 3 times the square root of 5 over 5. Now we no longer have a square root on the bottom. So when we're simplifying 3 over the square root of 5, we have to multiply it by the square root of 5 over the square root of 5. And then we're going to get an answer that has no square root on the bottom. So that's all we're doing today is we're figuring out how do we get rid of this square root on the bottom. Let's check out another one. Let's do the square root of 5 over the square root of 4. Well, should we multiply by the square root of 4 over square root of 4? Wait, no. First, look, that's a magic number. The square root of 4 is 2. So this one actually simplifies and solves its own problem. So that one's done. Now, I'll actually make some boxes so we don't get all mixed up here. We can kind of see our different problems. So let's take another one. Let's take square root 5 over 7. First step, separate it into the square root of 5 with the square root of 7. Why do I separate it? Because then you're better able to keep track of everything that's going on. Now, I can't have a square root on the bottom. We just talked about that. So how do I solve this? How do I fix the problem? Well, I fix the problem with the problem. So what's the problem? The problem is the square root of 7. So I'm going to multiply top and bottom by the square root of 7. So the top square root of 7, square root of 5 times square root of 7 is the square root of 35. Square root of 7 times square root of 7 is square root of 49. Oh, but you didn't get rid of the square root. Oh, but that's a magic number. That is, the square root of 49 is 7. See a pattern here? When you multiply by the square root, right? This is essentially the square root of 7 times 7. Well, the square root of 7 times 7 is 7. So that's why we're doing this, is because we can fix the problem. If we multiply a number by itself, then we get the square root of that number is the number. That was a lot of the numbers, but here's what it is. The square root of 7 times the square root of 7 is the square root of 49. The square root of 49 is 7. Okay. So there goes the basic ones. Now, we're going to take it up a notch. And I'm going to introduce you to a new vocabulary word. Conjugate. Conjugate. And what conjugate means is opposite. Conjugate just means the opposite. So why do you need to know that? Well, sometimes our denominators aren't this simple. Let's say you have something like 5 over 2 minus the square root of 3. 5 over 2 minus the square root of 3. Oh boy, we have a square root of 3. Now, unfortunately, since there's a minus here, this is a unit. This is a binomial. And so we have to deal with this whole binomial. So when we're going to fix the problem with the problem is actually this whole thing, the 2 minus the square root of 3. So to fix the problem with the problem, we're going to have to multiply by the conjugate. And what's the conjugate? The conjugate is the opposite. The conjugate is 2 plus the square root of 3. 2 plus the square root of 3. So we only use the conjugate when we're dealing with binomials or trinomials or anything like that. If you're just dealing with a monomial, you could just do this. So this is your first option. But if you have a binomial, you're going to have to do this. And now if you remember, this is distribute. So this right here is 5 times 2 plus the square root of 3. So you're going to have to distribute the 5 through. 5 times 2 is 10. 5 times the square root of 3 is 5 times the square root of 3. Now, the bottom, we have binomial times a binomial. So I'm actually going to make boxcar troll. We're at 2, a negative square root of 3. We're at 2, a positive square root of 3. So I've got 4, negative 2 times the square root of 3, 2 times the square root of 3, and negative square root of 9. So if I write this out, I have 4 minus 2 times the square root of 3 plus 2 times the square root of 3 minus the square root of 9. These, negative 2 times the square root of 3, positive 2 times 3, those cancel out. So I'm left with 4 minus the square root of 9. That negative was with this one. So that negative got used up. That negative is right there. Look at that. The square root of 9, that's 3. So it's 4 minus 3. So that would be 1. So this would be 1. Wow, that worked out kind of nice. So I have 10 plus 5 times the square root of 3 over 1, which if we simplify is just 10 plus 5 times the square root of 3. I didn't realize that times that would give us 1. That was nice. All right. So let's do one more where we find the conjugate. let's see our problems here. Okay. Let's do 3 over 4 plus the square root of 2. So, what's our problem? Our problem is that we have a square root on the bottom. What's our solution? Well, our solution is to multiply by the conjugate, multiply by the opposite, or minus the square root of 2. Okay. The top we distribute. So we have 12 minus 3 times the square root of 2. But on the bottom, we have two binomials. So we are actually going to do boxcar rules. 4 square root of 2, 4 negative square root of 2. So I have 16, 4 times the square root of 2, negative 4 times the square root of 2, negative square root of 4. So I have 16 minus 4 times square root of 2 plus 4 times square root of 2 minus square root of 4. So these two, negative 4 times square root of 2, positive 4 times square root of 2, those two cancel. So I have 16 minus the square root of 4. 16 minus the square root of 4. Look at that. That is a magic number. So I have 16 minus 2. It's 14. 12 minus 3 times the square root of 2 over 14. So that's how you use the conjugate to simplify a fraction such you can take the square root out of the denominator. Okay, let's do a couple problems. Okay, what happens if we have something that we can simplify? Well, let's simplify it first. So we have the square root of 15 over the square root of 100 times the square root of 5. Well, look, that is 10. So it's a lot easier if we simplify it first. So we have the square root of 15 over 10 times the square root of 5. That's a little bit easier for me to deal with because I still have the square root in the denominator. So fix the problem with the problem. 10 times the square root of 5, square root of 15 times 10 times the square root of 5. So this top, I have 10 times the square root. What is 15 times 5? Ten times the square root of 75. Oh, I see there's a magic number inside there. And then this will be 100 times the square root of 25. So, got a magic number right here, which is 5. So I now have 500 on the bottom. 5 times 100 is 500. And on the top, I have 10 times 25 times 3, right? 75 is 25 times 3. Well, that's a magic number. That's 5. 10 times 5 is 50. So I have 50 times the square root of 3 over 500. Now, should I simplify these? No, because this is an irrational number, so I can't not like terms. But there's my answer. All right. So give those a go. I'll give you a little hint, something like this. This one I'm going to have to multiply by the third of 16. Boy. Oh no, this one. Oh wait, what's 16 times 16? That might actually work. 256 does not work. Doggone it. Might have to multiply it by a third of 16 again. The cube root. So you get 8 times 3 to the 256 over 4096. Oh, well, that's a magic number. That is 16 times 16 times 16, or 16 to the third. So you get 16 under 8 cube root of 256. Cube root of 256 is 4 times 64. That's a magic number. That's a magic cube. And that is 4. So you have 4 times 8. That's 32. Times the cube root of 4 over 16. Okay. Don't forget to solve the problem with the problem. So we're going to do our conjugate. So we're going to multiply this one by 3 plus 3 to the third. Actually, that's going to be negative 3 plus 3 to the third over negative 3 plus 3 to the third. All right. Ask me if you have any questions and do your best.